In this ACT math video, we're going to take a look at exponential equations. In other words, you have two bases, they raised to powers, and you have to find the value of x in the equation. So at this moment, you can either stop the video and try to solve the problem on your own, or you can keep going and we'll work into getting the solution. So before we deep dive into the problem, let's take a look at a basic exponential equation. So you can probably look at this equation and easily tell what the value of x is. If your guess was x equals 5, that is correct. And just notice that because the bases were both 7, it made it easy to tell what x would be. Now, if it was 8 to the x equal to 7 to the 5th, it would have been a lot harder to tell what x would be. And so the main point I want to make from this is that when the basis or the big number is the same on both sides, you can set the powers equal to each other. And that's the approach we're going to use when we solve this problem. Now let's take a look at this problem. So it looks kind of hard at first because the bases are not the same. However, we can make both bases the same by noticing that they are both powers of 3. For example, 27 is equal to 3 to the 3rd power, and 9 is equal to 3 to the 2nd power. Using those facts, we can transform the equation. So we have currently 27 to the 3x minus 4 is equal to 9 to the x plus 1. 27 is equal to 3 to the 3rd. So now we have 3 to the 3rd to the 3x minus 4. And 9, which is 3 to the 2nd, that gives us 3 to the 2nd to the x plus 1. Continuing on, we can distribute. We can distribute the 3 into the 3x minus 4, and we can distribute the 2 into the x plus 1. And when we do that, we'll end up with 3 to the 9x minus 12 is equal to 3 to the 2x plus 2. Now that the bases are the same, we can set the powers equal to each other. So in order for both sides to be equal, 9x minus 12 has to equal 2x plus 2. Solving the equation. We're going to have 9x minus 12 equals 2x plus 2. And we can solve this by bringing the x's all to one side. We can subtract 2x on both sides. That's going to give us 7x minus 12 equaling 2. Then we can bring the 12 over to the other side. 7x is equal to 14. And finally, canceling out multiplication, we can use division. And x will equal 2. So in order for both sides to be equal, x will equal 2. Answer is C. Another way to solve the problem is to plug in the answer choices until you get the correct answer. So what we'll do is we'll let each answer choice be the value of x, and we'll just plug them in until we find the first answer that works, and then we'll move on. Let's first plug in x equals 0. You're going to end up with 27 to the 3 times 0 minus 4 is equal to 9 to the 0 plus 1. That's going to give us 27 to the negative 4 power equals 9 to the 1st. Using a calculator, you're going to end up with 0.0000019 is equal to 9. Obviously, that's not true, so we know this is the wrong answer. Now let's try x equals 1. So we're going to plug in x equals 1. You're going to end up with 27 to the 3 times 1 minus 4. And that has to equal 9 to the 1 plus 1. That's going to give us 27 to the negative 1, equaling 9 to the second. 27 to the negative 1 is 0.037. 9 to the second is 81. They're obviously not the same, so we know x equals 1 doesn't work. Now let's try x equals 2. See if that works out. And so this is going to end up being 27 to the 3 times 2 minus 4, equaling 9 to the 2 plus 1. And that's going to end up giving us 27. That'll be 6 minus 4, which is 2. 27 to the second power equals 9 to the third power. And when you work those both out with a calculator, they both come out equal to 729. So it does look like x equals 2 is the right answer. The answer is C. Feel free to visit mathonthefly.com, where we have over 100 ACT math worksheets that cover a variety of topics. And while you're at it, feel free to join our mailing list so you can get updates on everything that's going on. We also offer an ACT math book that's in paperback form on Amazon and also in PDF form. With that being said, I hope you liked the video, and I'll see you in the next video.